Hey everybody, this is Larry. This is me doing an extra random algo prompt I haven't done yet, just to kind of get a new one, get my money's worth, all that stuff. It is Jan 22 of 2024. Let's go. Maximum subtree of the same color. It's a premium prom, it's a medium prom, it's a Microsoft prom apparently. And we'll see. Yeah, hope everyone's doing okay. Just came from the gym, passed out a little bit, but hopefully after this I'll cook some delicious proteins and yeah, and call it a day. But yeah, you're given a 2D array of edges representing tree with end nodes numbered 0 to 1 or 0 to n minus 1 rooted at node 0, where edges of I is equal to u sub I. V sub I means there's an edge from node to v sub I and u sub I. You are also given a 0 index integer array colors of size n, where colors of I is the color assigned to node I. We want to find a node V such that every node in the subtree of V has the same color. Return the size of such subtree with the maximum number of nodes possible. Man, I have no idea what it's saying. Wasn't paying attention. I don't know. Sometimes I do need to figure out how to do better focus. It is one of those things where, yeah, it is just one of those things where, I don't know, you read the words and then it just doesn't tick. So, okay, that's good. So you have some edges and then you have some colors. Okay. You're going to find a node V such that every node in the subtree has the same color. Okay. Return the size of the sub. Okay, I mean, that's pretty straightforward. I mean, the key thing to notice is that, yeah, I don't know, I didn't read it the first time. But the key thing to notice is that, it's a, one is that it's a tree, so there's a recursive structure, but the problem also has a recursive structure, right? In the sense that once it becomes force, it will just be force. And yeah, and we can kind of calculate node by node. You can also return stuff as you go. That is probably a clean way to do it, but it's a little bit messier it's a lot more bookkeeping, I think. So I don't know, we'll see. But yeah, but I think at the end of the day, it is just going for it. Oh, it's not a binary tree. That's another thing to kind of note, by the way. But that's fine. So then, first of all, let's create the adjacency list. Let's call them. Let's actually call it that way. Right, collection start default dict of list, and then now for UV and edges, then adjacency list of you. Just creating the adjacency list, right? And then now we want to just do a traverse on node 0. Let's just say best is equal to 0, and that should be good. I mean, of course, the magic is in filling out the traverse function, so let's do that. And we actually want a parent because we want to go down a tree and the parent, right? Okay, so yeah, and then now it's just for V in adjacency list of node. Basically, this is the children, and we want to return. So what are the colors going from? Colors.length. So colors can be any number from 1 to 10 to the 5th. So maybe we can set yeah, maybe we could use like a -1 as a thing to kind of return, right? So we want to, I want to say for now, maybe we'll clean it up a little bit, but return 2 things, right? We want to return the number of subtree nodes, and then also I don't know how many colors or something, even just like, is it only one color? So almost like a Boolean thing, right? And what color? If it's only one color, then we can return the color, right? So yeah, so then now for V in adjacency low, we want to traverse V with the node as the parent, as long as V is not the parent, so we don't go back up to the tree. And then this gives us, as I say, 2 things. So maybe like a count and a color, right? Yeah. So the key thing to note is also, I don't know why, sometimes I spell color the British way, but note that this color, we only, okay, so let's say this total node first, right? this color only matters if it is not the current color, right? So yeah. So maybe I could write return color is equal to node dot color. Oh no, it's color subnode. And then here, if color is not equal to the return color or node color, maybe node color is a cleaner way. But in any case, if it's not the same, then we set it to -1. And that basically is what we're going to return, right? And that's really it, right? Because I think, I don't know if this is true, maybe I lied. But yeah, if this is negative, if this returns -1, then this is going to return -1. Then yeah. Then if it returns -1, that means the subtree is already not the same, not one color. And if it is not, then we can just, then we'll just set this anyway. So then now we can just, and technically actually S total is 1 because you have to count the current node. And then now we can return, what did I say? Total and then our color, right? But if our color is not equal to -1, that means that there's only one color in the subtree. Then we can update best total. And then that's pretty much it, I think, I hope. Yeah, and as we only go to each node only once, this is going to be linear time, linear space. And yeah, and there's some, or I guess this is a tree, right? So yeah, so edges is going to be also linear, right? Or you can say V or Y, but they're both like, Y is equal to V -1, right? So yeah, that's pretty much it. I think the kind of definitely you can make this problem as complicated as it can happen sometimes. I think the key part about this particular problem, like the trick to this problem, if you will, I don't think it's a trick, but the observation that you need to make is that it's about like the function recursive invariant, right? And the invariant is just that and this is an obvious statement if you say it out loud in English, but if the subtree of all the nodes are, if a subtree of a node is all the same colors, then recursively that subtree also, or like each of its children, those subtrees are also the same color, right? Like, yeah, so those mini subtrees also all have the same color, and then you kind of think from that logic, kind of build it up backwards, and that basically makes the code really tight, right? This is pretty standard, or pretty, I don't know if it's standard. I mean, it's not that standard of a problem per se, but yeah, it is just like a very clean code, I think, for the most part. I mean, okay, maybe there's some naming, and maybe you could say we can also return the best, but I don't know, it's fine, right? But yeah, that's all I have for this one. Let me know what you think, and yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.